Joe, and also for inviting me to this conference. You asked me to give a presentation about the ATIS project in the Netherlands, how it develops during the last year, and I hope it could be inspiring for you to move on with your good initiative and all the people who are participating in this conference. I heard already many very nice presentations, so I hope this presentation can contribute to your plan. Let me introduce myself a little bit because I think you don't know me. Can you see my screen? Presentation mode? Yes? Okay. So my name is Bas Godschalk and I studied geochemistry, and the last 14 years I worked for the company IF Technology. And at the company, I'm the international business manager to promote the ATIS business abroad. Our company is an engineering and consultant company specialized in shallow and deep geothermal projects. And in the Netherlands, we have our office, and about 75 highly educated specialists are working on all kinds of questions from our clients. And our clients are mostly present in the Netherlands, and a few of them are also abroad. Now, we are now working already 30 years on geothermal projects, and these are the main solutions we are working on. So this gives an overview of the borehole thermal energy storage system, which is an application especially for smaller projects, smaller buildings. But we also worked a lot on the aquifer thermal energy storage, which is our main technology, especially valid for bigger buildings. We also work on geothermal projects. And during the last years, we see that we spent much more time on using energy from surface water, which is a very interesting technology and which can also be combined with ATIS. And we also hope that this technology can help to supply more and more buildings with sustainable energy. Let me go a little bit in more detail to the aquifer thermal energy storage systems. I think the most important is that you really store the seasonal heat and the seasonal cold in your subsurface. And by storing this energy, you can reuse the heat from the summer during the winter time. And during the summer, you can cool your buildings directly by the cold water which has been stored in your aquifer. Important is that we only have a very small temperature difference in the aquifer. So the normal temperature is about 12 degrees in the Netherlands. So our cold well will become about 7 degrees and our warm well become about 17 degrees. This results in a very low impact on the chemistry and physics and microbiology in the subsurface. Another very important point is that there is no depletion of groundwater. So the amount you abstract is exactly the same you inject. And that is a very big advantage when you also want to protect and take care for your groundwater resources. And of course, very important is that your energy delivery is very efficient. So your CUP is very high. Let me give some examples of some projects. On the left side, you see the Technical University of Eindhoven, which is one of the biggest ATIS projects in at least the Netherlands, and I think Europe and maybe the world, which is developed during the last 20 years, starting with a small heating and cooling grid, connecting a couple of wells, connecting a couple of buildings. And during the years, they expand by adding more wells and also more buildings. This is a very smart grow model, which is yes, spreading the investment cost during the years, but in the meantime, you can already have the savings of your investments. Second project in the middle, it's in Amsterdam. And if you look at the numbers, you can see that the max flow rate will be about 500 cubes per hour for 2 wells. So that means that we can abstract here with just one well with 250 cubes per hour, which is a very high rate and which can only be done around Amsterdam, where we have a very nice sandy aquifer. When we look where ATIS projects are realized, then we see that more or less half of them are the commercial buildings like offices, and other ones are the hospitals, greenhousings, public buildings, and also the industry. A smaller part is the residential area, but that will change, and I will tell later about that trend. When we look at the Netherlands in 1990, there were only a couple of systems, but during the years you see that the amount of system is expanding, and at the moment we are counting around 3,080 systems. When we look worldwide, then we see that also in Sweden there are many systems in the southern part, and some in Belgium, also in the UK, which we also worked on in London and Birmingham, some in Germany and other countries, but not very high amounts, and especially not when we look also for bigger systems. In many countries you have some combination with groundwater abstraction with small wells and heat pumps, but not the big applications. Why? Why is the success in the Netherlands, and why could it become also a success in Ireland, in Northern Ireland? I would go in a few details. I think one of the critical issues is, of course, you need an aquifer because you need to abstract and inject the groundwater. So we have very proper aquifers, and that means that nearly everywhere in the Netherlands you could apply this technology. So that makes it very attractive also for project developers to start up a project because they more or less know that they can apply it. And we have also a very good database which is freely accessible at TNO, and you can have a very accurate idea of how are the layers built up, which means that you can save on the initial cost like doing a test drilling. And this is very important because then you can move on quickly. But it's also very important that you have a good climate because you use the seasonal heat and the seasonal cold to store it, and you reuse it in the next season. And we have seen that especially cooling is very efficient with COPs between 30 to 40, which means that you can have a very attractive and good business case. That will really help. I've just worked out a very small business case for a project, a building in Belfast. I did some assumptions just to show you a little bit, to get a little bit feeling of the numbers. It's a big building with 100,000 square meters. And based on the starting points, I made an energy concept. And by using the energy concept, I made a cost calculation. And in the upper part of the table, you can see the investment costs. And of course, the ATIS solution will be more expensive than the conventional heating and cooling by gas and using chillers. But when you look at the exploitation cost, you will see that the energy costs are much lower than in the conventional way. And that brings, if you divide these numbers to each other, that your return of investment would be around 2.5 years. Of course, it depends on the starting points and assumptions you make, but it's a quite normal number in the Netherlands that your return of investment will be between 2 to 7 years. So you also see in the last part that you can have serious CO2 savings by using ATIS. What's also very important is that we have a proper legal framework, because you see in countries where there's a lack of a good framework that project developers are not willing to invest because they're quite unsure if they can run their system for many years. And that's why it's very important that you work on a very good, reliable framework where it is clear what you have to submit to get your permit, and that you also have a clear demand what you should measure during the time. And don't ask too much, because then the exploitation cost will become very expensive. What's also very important is that you know that there are different interests which you should bring together. So one department want to save energy, the other department want to protect the groundwater, and the project developer want to earn money by using or developing good and green buildings. So you have to bring these different interests together and put the point on the horizon where you want to go, and then to think how you can combine this interest to have a good legal framework. As mentioned, the return of investment is quite interesting. In the Netherlands, there's no subsidy for ETA system, but the government supported the technology by investing in research. So we solved in the beginning the clocking problems. We improved the drilling methods, because that's very important to have a reliable well. And during, after a couple of years, we did a very large research to measure all the impact on the chemistry, on the physics, biological processes, etc., which is summarized in the Meer met Bodemenergie brochure. In some countries, some cities, we see that there are so many ATIS projects that the underground becomes a little bit crowded. So some cities start to plan the ATIS systems, because they think that will be better to get more systems realized, and that they won't compete to each other, but contribute to each other by making cold zones and warm zones. What you see in the trend during the last year is that we started that each building will have its own ATIS application, which is from a very practical point, because it's more easy to manage such a type of systems. But when you look at complexes like the university complex of campuses, then you see that they start to reconsider this concept, and they see the advantages of combining ATIS systems together. So that's what's in this picture. On the left side, you see there are individual ATIS systems, but we are working to the new situation where we have a heating and cooling grid combining all these systems, and that you also can exchange heat and cold between the buildings. So a laboratory needs more cooling, while the residential areas for the students need more heating. Another trend in the Netherlands is that the residential areas are becoming more and more important for the ATIS business, because the authorities has decided that we stop heating houses by using gas. So all the project developers has to find new solutions. A new solution could be that we use ATIS, unless the business case is more profitable for cooling, you combine it and also use it for heating. And we see that it will be often also combined using surface water as an energy source. So that is the most important. So I really hope that it all has to do, of course, with game changes. Entrepreneurs who really want to do, people who are very curious to do research, etc. So I think if we can work together, and we are open for sharing information, for giving trainings, or showing you Dutch projects, you are welcome to come to the Netherlands if the coronavirus has been a little bit back. So I hope that we can collaborate in future. Thank you very much for your attention.